So now we get into actually doing Lewis structures. So here's guidelines for writing Lewis structures for molecular compounds. Start with the correct skeletal structure. In some ways, that's the hardest part. How are the atoms connected to each other? Because sometimes there's several possibilities. And so for right now, the guideline is the hydrogen atoms are always terminal, and we generally put more electronegative atoms in terminal positions. So what's a terminal position? Terminal means end, right? So these go on the end, these are on the outside. Hydrogen has one electron, it can only form one bond. So it can't be in the middle making bonds with several different atoms. It has to be on the edge, okay? After we do that, then we're going to calculate the total number of electrons for the Lewis structure. So we look at the valence electrons for each atom and we add them up. Remember, group number tells us how many valence electrons an atom has. For ions, then we have to consider the charge. We're going to distribute the electrons among the atoms, giving octets or a duet for hydrogen to as many atoms as possible. Try to spread it around and make everybody happy. If you don't have enough electrons, then you'll have one or more atoms that don't have an octet, 8 electrons. And so then you may need to form double bonds or triple bonds. Because if we don't have enough stuff, that means we have to share more, right? So that's what we do with the electrons. So let's do some examples. Write the Lewis structure for carbon monoxide. So first step is skeletal structure. How are these connected? Well, 2 atoms, there's no choice. They have to be connected to each other, right? So there's carbon and there's oxygen. And I think it's a good idea to go ahead and draw that. There has to be at least a single bond there, so just draw that. The next step is find out how many valence electrons do we have to deal with here. How many does carbon have? How many valence electrons? 4. And how many does oxygen have? 6. So that's 10 valence electrons. Everybody okay with that? So I have 2 in that bond. And on this slide, I'm going to go ahead and draw the electrons on there. So you have to count each of the bonds as 2 electrons. And this is a lot of counting by 2. So there's 2, 4, 6, 8, 10. There's no set way to put the electrons in there. I like to just sort of, spread them around evenly. But if you want to start on one end and work your way over it, you'll eventually get to the same thing.
And there's always one, at least for each bond, there's one.
There has to be at least one bond, and a single bond has 1 electron on each end. With, that's the way it gets drawn. So each bond is a pair of electrons. So there's my 10 electrons. Do we have octets? No. So that means that carbon and oxygen need to share some more. So I can take a pair of electrons from, say, the carbon and put it in here and have it be a bonding pair instead of a lone pair. So I can move those electrons, and now it's a bond. I still have the same number of electrons. I'm not adding electrons, I'm just moving them around. Now do we have octets? Oxygen has an octet. Oxygen's got 2, 4, 6, 8. But does carbon? Nope. So I'm going to take another lone pair and make it into a bonding pair. But I'm going to take from the atom that has enough, and that atom's going to share with the one that doesn't have enough. That saves time of moving things around later. So instead of moving this lone pair in, I'm going to take a lone pair from the oxygen, because oxygen's in a good place, and so oxygen can be generous and share with carbon. And now we have an octet for everybody. For an octet, we're looking at this element. So here's carbon, and we're counting how many electrons are directly around it. So there's this lone pair, that's 2, and each bond is 2. So 2, 4, 6, 8. And this oxygen counts 2, 4, 6, 8. Octets. Good. Now, that looks kind of ugly. So that typically happens. By the way, pencil is really good for Lewis structure drawing because there's a lot of erasing. So I'm going to draw it more nicely over here now that I know what I'm doing. So there's carbon and oxygen with the 3 double bonds. I mean the 3 bonds, the triple bond, 3 double bonds, and then the lone pairs. Now, you don't have to put the lone pairs on the outsides like that. It doesn't really matter, but I think it looks nice. Yeah.
So you're saying in order to be complete, most of the elements need to be enough.
Yes. Yeah. So we're going for making everybody happy, and happy is 8 electrons, unless you're hydrogen, and then you're good with 2 electrons. Any questions about that one? Let's do H2CO. So this one's a little more complicated. So first thing is we have to decide, well, how are we going to connect these things? Well, hydrogen can't be in the middle. So how about we put carbon in the middle? There's carbon, and we'll stick a hydrogen over here. And there's going to be something else bonded to the carbon. It can't be, well, we have the oxygen in here somewhere, right? And then the oxygen, we got a choice. We could put it on the carbon or we could put it on the oxygen. Put it on the oxygen? Okay. Let's do both. Do both of them. See what happens. So the guideline, so I happen to know this is the correct one. The guideline that we had in the rules was to put more electronegative elements on the outside, and oxygen here is the most electronegative element. And so that guideline would suggest having the oxygen be terminal, meaning only connected to one thing. But we're going to learn a couple of different ways to identify how we should put these together. We're just not there yet. So then we need number of electrons. So we have 2 hydrogens. They each have 1 valence electron. We have carbon with 4 and oxygen with 6. And so this structure has 12 valence electrons, right? So looking at this one that's a line, we've got 2 electrons, 4, 6, 8, 10, 12. And over here we'll do the same thing, 2, 4, 6, 8, 10, 12. Not enough, right? Not enough electrons for an octet. In both of these, the carbon has an octet, the oxygen does not, right? Here the carbon has an octet, the oxygen doesn't. So then carbon is going to be generous and share with oxygen because oxygen doesn't have enough. So we're going to take this lone pair and make it a bonding pair. So now there's a double bond between carbon and oxygen. So this carbon still has 8, 2, 4, 6, 8. Now the oxygen also has 8, 2, 4, 6, 8. Hydrogen is always good. He only needs 1 bond and that's it. So then over here we're going to do the same thing. We're going to take a lone pair from the carbon and make it a bonding pair with the oxygen and end up with that. So both of these are giving us octets. We're going to learn something in a few minutes called formal charges that'll help us decide which of these is better. But I'm also going to show you kind of a shortcut to that. that can just really speed up how you draw stuff. So let's just look at some of the, oops, not that one. Some of the common elements. Oh, that's going to be too close. How many valence electrons does hydrogen have? As an atom? 1. And how about carbon? 4. 1, 2, 3, 4. Nitrogen has 5. 1, 2, 3, 4, 5. Oxygen has 6. 1, 2, 3, 4, 5, 6. And fluorine has 7. Let's just make sure these aren't running together, because those guys are getting a little close there. So when we look at fluorine, how many unpaired electrons does it have? 1. Fluorine, oops, that's really crooked. Fluorine tends, okay, let's try this again. Fluorine tends to make 1 bond with that unpaired electron. How many does oxygen have? 2. It tends to form 2 bonds. Nitrogen has 3 unpaired electrons. Well, that just gets kind of weird looking, but 3 bonds. Carbon, 4 unpaired electrons, 4 bonds. And hydrogen, 1 bond. That's what they usually do. They don't have to do that, but they usually do that. And so if you can get that, it's usually better. So if we look at this one where we have them all in a line, how many bonds does this carbon have? 3 bonds, right? A single bond with hydrogen and a double bond with oxygen, so that's 3 bonds. How many does this oxygen have? 3. Is that what they like? No. Over here, how many bonds does the carbon have? 4. And how many does the oxygen have? 2. Oh, that's what they like, right? This likes 1 bond, 4 bonds, 3, 2, 1. So that can help. But at this point, I would accept either of these. And so to straighten them out and make them look a little better, we draw that one like that, and this one like that. It can be tricky knowing how to stick them together. And there's just going to be, you're going to make a bunch of mistakes, and you're going to have to fix it, and so just be okay with it. Any questions?
So we can look at the electronegativity is inversely related to the atomic size also. And we're doing this to figure out which one should we turn.
Yeah. In general, the ones that are more electronegative are going to be on the outside, not on the inside. And of course, all of these are general guidelines, right? Can be exceptions. What if we have a polyatomic ion? We have to consider the charge. So you add 1 electron for every negative charge, and you subtract 1 electron for every positive charge. And that kind of goes backwards because it says -2, but I'm adding 2, and it doesn't seem right. Just think about, well, why does this thing have a -2 charge? Because it has 2 extra negative electrons, right? And then we write the Lewis structure, and then we put brackets around it and put the charge on the outside of the brackets. So let's do hypochlorite ion, ClO-. And here's another nice one where we don't have to decide how to put them together. There's chlorine and oxygen. They got really big somehow, I don't know. How many electrons do we have? Chlorine has valence electrons. How many? 7. And oxygen has 6. We determined that already. And then that -1 charge, do I add an electron or subtract? Add. So 14 valence electrons here. So I have this one bond, that's 2, 4, 6, 8, 10, 12, 14. Cool. I had enough. Everybody has an octet. To finish this off, though, I need to put brackets around it and write the charge on the outside of the brackets. We don't want that charge getting lost among the dots, so the brackets kind of help say, okay, this whole thing, and there's the charge.
For polyatomic ions, are they usually just going to add a full octet? Or is everything going to be?
Well, there are exceptions to the octet rule, but these, like the oxyanions, well,
It's okay.
yeah, we'll get to that.
There's a first problem for the first sheet, that's exception.
Yeah. So any questions about this one?